We will continue the discussion on chapter 6. So we will start with method design. If you remember, we covered the static methods. The main things that we covered so far yesterday were interfaces, and then we have talked about the enumerated types again. And method design, this is again something you have seen before, but there are certain things we would like to repeat just to make sure we are on the same page and we understand how the method design actually should be done. When you look into the high-level design of a program or a software, what you do is you identify the primary classes and objects, as we said, and that's critical because you have to design your classes and objects in the most effective fashion, so that's important. And we assign the primary responsibilities to these components, the classes and objects that we have designed. So that should be clear. From that point on, what we have to do is from high-level design we will start with, and then we will continue to implementing the low-level design, which is going to include the methods that are going to be part of your classes. So if you have created a certain class to perform certain tasks, what you would like to do is that you would like to start writing the methods that are going to be implemented within this class declaration or class representation. For some of the methods, you may use them directly as implementing the tasks. For some others, you may want to use supporting methods that are going to be used in implementing the main methods that you're going to implement. So in order to come up with an efficient and elegant design, you have to be careful with the method design such that you utilize the methods that you have written so far. You reuse the same methods, so you don't go repeating yourself and writing the same method over and over, or portions of the methods shouldn't be repeated over and over. So you should avoid those overlaps and design a nice elegant method distribution into your classes. So when we look into an algorithm, it's a step-by-step process of performing a certain task or attacking a certain problem, such as a recipe for a food, or travel directions to going from one location to the other one. So these are represented again with certain rules followed one after the other one. And in our method designs, what you would like to see is that before going into writing the actual code, what you want to do is that you would like to come up with the algorithm, how internally you're going to implement the actual code. So before going and writing the code itself, it's rather better to think about the problem and think about how to attack it. For example, if you're going to search for an element that is existing within a list, let's say you have an array of elements that you're going to search from, how are you going to search this element? What path should you follow? You should try to understand the problem first, and then create the method accordingly. And this is usually before going into the low-level language implementation. What you write is a pseudocode. This is the pseudocode that we mean is that it is not exactly low-level language-dependent code, but rather a language close to the language, natural languages, but at the same time it is possible to represent it with a code. For example, let's say you would like to check whether a value is between certain ranges. What you would say is that instead of writing the details of the Java code itself, what you would say is that if x is between 5 and 7, for example. So this kind of implementation, it is not in the natural language, and also it is not in the programming language that you are going to program into. So it's midway in between, which will be easily converted to a programming language if you take the pseudocode, right? This is the pseudocode. It is easily convertible to the programming language representation. This could be Java, this could be C, this could be any language that you have. Once you have the pseudocode, you can easily convert to the programming language. At the same time, when a human being who doesn't know any programming language can understand it easily by looking at your pseudocode. So it's a midway between a natural language representation and a programming language. And this is usually, in design documents, this is usually provided to the user so that he or she has an idea of how this is implemented internally. Okay, so this gives an abstract view of the program and the method that you write. And this is usually a good starting point, because if you write this down, you know what are the things that you need to pay attention to, and how you are going to program it will be easier once you have this pseudocode. So we usually use, this pseudocode representation in representing the algorithms. And one key thing that you would like to pay attention to is decomposing the methods. So you could have one single big method that is going to take care of everything in one shot, or you can, divide it into smaller pieces and try to manage them in smaller pieces rather than implementing it as a whole. So you would like to, divide a potentially large method into smaller pieces as much as possible to decompose it into manageable pieces. So that's the way you should be trying to do. One thing is that it will be more clear what are the inputs and outputs of each method, and then you know which portion is going to work for doing what. So you know the distribution of the tasks among these methods. That's one advantage. And then the other advantage is that you will be able to easily traverse any problems in your methods. So you can, if you identify that one of the methods is problematic, let's say you have multiple steps that your whole method is following, so you distribute the one big method into multiple pieces, and they have input that is taken from the first method, and then you give it to this second method and it generates an output. By looking at these inputs and outputs, you can see which method is problematic if there is a problem. So that's also important in method decomposition. So you would like to decompose it into smaller pieces such that you can understand if there is a problem in any one of those implementations, and just concentrate on that part only. So if you find that this is the problematic part, you can just concentrate and solve the problem here. Once you know it generates the correct input, then you are sure that this part is fine. Let me concentrate on the rest of the methods. So this will provide a better understanding of the, again, the working of your algorithm. So in that sense also you would like to decompose it into smaller pieces. A third advantage is that you can use one of the methods that you have created in a totally different purpose. Also that is possible to use it for, let's say, another method that needs such an implementation. So you can just take this method and then use it there for that other application that you're trying to use. So it's always good to decompose it into manageable smaller pieces. However, after a certain point you can you cannot decompose it, so it must stop at certain point. So you have to come up with the good design by thinking which is the most suitable for your application. So so you can use a public service method to call one or more private support methods to help it accomplish its goals. So you can, if this is the public method, you can create multiple, private methods that are specifically going to be used by this single method. You can do that. So let's look at an example to make it more concrete. So if you look into this Pig Latin language, it's kind of a weird language where you have, for English letters such as book, you have the first letter taken as the last letter, and then add an AY character sequence so that your book will be converted to ukbey. And then for table, again, able remains same, and table comes to the end, able te. And if you have a vowel that at the beginning of the letter, what it is converted to is something like item yay. Instead of ay, you add yay for the words that start with a vowel at the beginning. Okay, so this is already described language, which which is given like this. So you'll just take this as a prior knowledge and then implement this language. Whenever if I give you a sentence that is composed of these words, how are you going to convert it to the Pig Latin version of the same sentence? That's the question. When you look into this example, you have the CH pair there are certain pairs, that we need to pay attention to. These are converted with the, again, this is copied at the end, air che. So that's how it is constructed for each word in Pig Latin language that is described already. So once you have this information, you're asked to design an application that is going to convert for a given sentence. How can you convert the string or a sentence into the corresponding Pig Latin version? How can you do that? So basically, you're going to first ask the user to enter the sentence, right? And then the user is going to enter the sentence. And after that, what you're going to do, that you're going to read the sentence and just parse it into smaller words. You will parse it into words. And then for each word, what you have to do is that you will check the first letter and then also check for the first two pairs. So if they're one of those pairs that you would like to modify, according to this, you are going to generate the corresponding word. So for this one, for this case, you will generate this. And then for this case, if it is a vowel at the beginning, you will perform this. If it is this kind of pairs that you have CH, ST, and compound consonants, if you have those pairs, then you are going to convert it in this way. So you have three options. You will select either one of them and apply the modification and generate the new sentence according to the given one. Right? So if you want to perform a method decomposition, what we would like to do is that we would like to translate the sentence. If we will look for natural ways to decompose the solution into pieces. So what are these pieces? We have the three options that begin with vowels. So this could be one of the methods that we call. And then we have begin with consonant blends. So such as the one I just gave as an example, SH, CR, TH, and all other consonant blends. And if we have words that begin only with single consonants. So we can have three different methods that is going to implement all of these one by one. And according to the condition, we will just call the corresponding method to perform the task. Again, you can perform this in one method as well. That's possible, but it's always easier and nicer to distribute and decompose it into smaller pieces because it's easier to manage that way. So let's see the Pig Latin Translator example here. So when you look into this example, so basically what we have here is that we have the main method for Pig Latin, and then we have the scanner that we are going to take from the user as an input from the system input. And we have the do while loop, which is basically going to read multiple entries from the user. So if you go and check the below part of this code, you see that we have a do while loop where the user is asked to enter another sentence, translate another sentence, yes or no. Based on that yes or no, case, another equals ignore case y. If the user enters either capital Y or lowercase y, it is going to continue and go back to the top of the loop and continue from there. And we're going to ask the user enter a sentence, no punctuation, and then we'll read the user input from the user. Then what we are going to do, we are going to call our Pig Translator class with its translate method, and then we will send a sentence as an argument to this, so that we want to translate this sentence and then generate a result based on that translation. So once we have generated that result, it will basically print that on the screen and then ask for another sentence if the user wants to. So that's basically reading the user input and sending it to the translator. So this is just the driving method, which we use for taking input and output. So when you look into the Pig Latin Translator.java file, you see that this is the translate method, which is basically taking a string as an argument and then also generating another string. So it basically takes the input argument and then generates the output. So we have the empty result string first, and then we have a scanner which is basically going to scan each word of the sentence that is passed as an argument. So this sentence is used as the scanner's input so that we scan each word of the sentence, right? And we convert the sentence to the lowercase, and we have, if in our scanner we have a next word, you know, the default delimiter in the scanner is what? What is the default delimiter? The space character. So we will be able to read the words one by one. Since there's no punctuation, it is asked from the user not to enter any punctuation. It is going to just have the words and the spaces so that we can get each word one after the other one. If our scanner has the next word in the scanner object, then we are going to translate this word into the corresponding Pig-Latin version and then append it to the end of our current result. So let's say if I have a text, so let's execute this. Enter a sentence. Let's enter a sentence. Book is really nice. So it's converted this to, as you can see, Uk Bey is ye, whatever, Ili Rey Isney. So it's the corresponding text. And what we do is that, you know, for each word we take, we translate it to the corresponding version of the Pig-Latin text. So when you look into this example again, I have this translate word method called with the next word every time. So I call this method and then convert the word to the corresponding Pig-Latin version and append it at the end of the current result. So this will continue until my scanner has the next word over and over, right? So it will start with the first word, convert it and copy it to the result, and the next one will convert the next word, and until this has more you know, words in the scanner object I have. And this translate word, if you remember, this is the method that we just called. So this is a public static method, and I have a private method, which is because basically we're using it within our first method, right? It is only used within this class, so I can perfectly you know, identify it as a private method. So again, this translate word takes a string word and then generates another string as a result. So what does it do? If begins with vowel word, this is another method which checks whether the string starts with a vowel or not. If the word starts with a vowel, what am I going to do? I'm just going to keep the word as it is before and then add a yay at the end, such as is, right? So we had this is, and since the first letter is, since it begins with a vowel, it is going to convert this to is yay. So that's what it is doing. And then if it doesn't begin with a vowel, I have two options. One of them is begins with blend word. So I'm going to check whether it starts with a blend such as ch, right? If that is the case, what am I going to do? I'm going to generate a new result. What is that result going to be? It is going to have the word substring 2. What does this indicate? It starts with the index 2 of the string passed as an argument, such as, let's say I have change. In that case, I will start with index 2. This is index 0. This is index 1, and this is index 2. I will have the substring that is starting with the 2 index, and I will append, on top of that, I will append the first 2 characters that will start with 0, and then 2 characters, which means the ch, right? So I will take that at the end of that eng, and so I will have eng ch, and after that I will add ay at the end. As a result, this will be the generated, you know, word of Pig-Latin version. And if it doesn't begin with blend, what am I going to do? I will generate the regular expression, which is going to just take the substring starting the first character after the first character, and I will have appended the first character after this, and such as book, right? So I will take this B and append it after this. So it's going to be ook B, and then I will append a y at the end, so it's going to be ookbay, right? So this is going to give you the three options we have. Again, the methods, we have the translate word, which calls two other methods, begins with vowel and then begins with blend. So we have two other methods. As you can see, you decompose it into smaller pieces. Now, again, since this is used in the class, it's called private, and I have the boolean, which returns true or false. If it begins with vowel, it will return true. Otherwise, it will return false. It takes the string word. And how does it perform this? So you have a vowel string, which contains all the vowel letters we have, A, E, I, O, and U. And then we get the first character of the string that is passed, which is this word. So we get the first letter. That's given by char at 0. And then I'm going to check the index of this letter within the string I have vowels. So how does it get the result? How does this method work? This is basically with this statement, right? It is going to try to find within the vowels, which is this string, the index of the letter that you passed, which is, let's say, book. In book, it is going to be B, right? So you will have B. Does it exist within this vowel string? That's what it is checking for. If it doesn't exist, it returns -1. However, if it exists, then it returns wherever it is. It could be from 0 all the way to 4. 0, 1, 2, 3, or 4. This method returns either 0, 1, 2, 3, or 4, or -1. If it doesn't exist, it returns -1, which means it is not a vowel, right? So that's what this is doing. Okay? Anybody who didn't understand how we achieve this? Okay. So we have begins with blend. So we need to check all the blends we have. How do we do that? This is how you do that. So this is the different combination of blends you may have, possibly. Obviously, you don't have to know this. But you have a method in the string library, string class, which checks starts with. So that's basically what it does, is that it checks whether your string that is passed as an argument is the one that you are starting with. If the word starts with this BL, it returns true, right? That's what this method does. If any one of these is true, any one of the combination of these two letter string is true, then in that case it is going to return true. Otherwise, it will return false. Okay? Any question? So this is another method which we call and use at the top when you go back here. So we have the main translate that calls this translate word, right? So we have the translate method. So we have the translate, and then we have the translate word, which then calls these two methods, which are, as you can see, begins with vowel, right? Vowel, and then you have begins with blend. So this is the method decomposition that is foreseen by this application. Obviously, you could have combined them into one method again. You could just do it in the translate method. But the idea is you will be able to see if your begins with vowel works correctly, if your translate word works correctly, and this will be more elegant to design if you write it in this fashion. Okay? Any question?
Why do we define supporting methods as static?
This one you mean?
Or the others. We define the supporting methods as static methods. Why?
What is the difference?
With the, what's the difference between?
Why do we need to define them all static?
If you are using a static method in your method call, you have to call static methods within that. So initial method is defined as static, as you can see here, the translate method. The reason why we define a method static is because you would like to access this method without any object being created at the time. So if you're going to use a static method, you know, the idea is because you would like to access this method as we do with the integer static methods or any kind of methods that we created with the string methods also. The idea is you can access those methods without having the objects themselves, right? So we don't need to create the object before accessing this method. We can just use the class methods as static methods. However, when you try to write this translate method, you have to use the static methods if you're going to access, because this is a static method, so it can only call static methods or static variables.
Inside it.
Inside it, yeah. That's why we define the rest of the methods static as well. So since this is a static method, you can only use static objects with this because there is no object that's associated with the class, right? So in that case, what you do is you use the static methods in the rest of the implementation. Since we're calling this translate word within this method, within this translate, it must be a static method also. Okay? Again, why do we create this as a static? Is that because if you go here with the Piglatin, this is how we call it, Piglatin translator.translate. Since we're using the static, we are not using any object here, we're just using the class name, we have to declare it as a static. You could have defined it as an object and run the method using an object too, but since there's no object involvement, you're not doing it multiple times. If you need to use this translator over and over, it will be a lot easier to do it with the static case. So when you consider the UML representation of the variables in unified markup language, the visibility of a variable or method can be shown also by using special characters. Public members are preceded by a plus sign. So in UML, if you have public members, they're used by plus. If you have private members, they're used using a minus sign. So if you look into this example, Piglatin is a public main method, has a public main method which returns void, so it starts with plus. And then Piglatin translator, which is used by Piglatin class, does have the translate method, which is the public and returns a string, and then the rest of the things are private, so they have the minuses indicating that these are private methods and private variables. So you can use this for the variables as well. When we come to the protected identifier, we will see how it is represented as well. So we will see protected in the coming lectures when we come to inheritance. So when we consider in our method calls, one key important thing is that you could give objects as parameters to your methods. So you can pass as an argument to your method an object which will be used within the method. Normally, what happens is that a copy of the actual parameter is copied in the base cases, right? With the integer or char or float, you copy actually the value of it. However, in objects, when you pass an object as an argument, if you remember, what happens with the objects? When an object is passed to a method, the actual parameter and the formal parameter become aliases of each other. What does this mean? Yeah, so you will actually referring to the same object with two different names. So if you modify one of the internal representation of one of the items, then the second one will also be updated. So whenever you have an object and you have a variable a that is keeping track of it, and if you give this object as an argument, then there is going to be a b that is referring to the same object. If you update one, the other one will be updated. Again, this is for objects only. However, if you have primitive types such as integer, float, it's not the case, right? So let's see this parameter tester and parameter modifier files. So basically what we have is that we have an integer that is given as A1, 111, and then we have two numbers that are objects of A2 and A3. So these are given as number objects, num. So we create this by calling the constructor. Let me open the file as well. So we have number.java. Okay, and if you look into the number class, what it does do actually is that public class num, and then you have an instance variable that is going to keep track of the value, private int value, and you have the constructor which is going to be just having an argument integer, and whenever you create the integer, its value will be whatever the argument is, right? And then set value, it is going to update the value of the number, so it's going to change the value according to the given argument. And you see that the toString method has return value and then the quotation. Why do I have the quotations here? To make it a string, so I append the quotation at the end so that this value is converted to its string version, and then you generate a string. So this is the number class, and when you look into the parameter tester file, you have integer A1, which is the primitive type integer 111, and then you have number A2, which creates a number object with 222, and then another number object A3 with 333 initially. So what we will have is basically with A1, A2, and A3 will be something like this. So we have in A1, since this is primitive type, we will basically store the result as 111. And then for A2 and A3, what we will have is that this is going to be A2, that is going to refer to object which has an initial value 222. And then we will have the third number, which is going to have again a reference to the number object, which will have an initial value of 333. So when we call this with the values, it's before calling change values method, it will print all these 111, 222, and 333, and then it is going to afterwards call the modifier.change values A1, A2, and A3. So let's go into the modifier. So this is the modifier that is defined as a class here. So parameter modifier. So let's go there. Parameter modifier. It's empty. So basically what it does is actually, in normal case, it should try to update That's weird. Anybody has the book? Olabilir mi? Did you check if this is the case with your examples as well? So basically, let me write the code here. So you have public, and then we have public void change values, and then you have int f1, and then I have number f2, and I have number f3, right? So this is going to be the arguments it's going to take, and then we will change the values. System out print line before changing the values, and then you have this. So I will just make it simpler. We will have f1 and then slash tab f2 and then another tab f3. So I will just copy this from here. Okay, I will print, what am I going to print? F1, F2 and F3, right? And after that, so this is basically before the method actually executes, it prints everything on the screen, and then next thing is we will update the values with a new set of values. F1 becomes 999, and we have F2. Since I cannot directly set the value, what am I going to use? I will use the set value method. Remember, this is the object again, right? F2 is a number object, so you can only set its value by calling the corresponding set method. Set value, and then I will have the corresponding number, and then I will have F3 equals new number, and this is going to be 777. Okay, now I will have the same exact thing, except that this is going to print system after changing the values. And that should be it. So let's try to okay. So again, going back to the modifier change value, so we just wrote whatever we did is, if you look here, we print the initial values before the method call and update F1 to the integer version 999, set value of F2 to 888, and then F3 will have a new number created for it with initial value 777, and then we will print those again at the end. And if you come here, after the modifier change values is executed, we will call this again. So if you trace this initially, what we will have is this, right? So I will have, with the method, I will have this. It's going to print, what is it going to print initially? It will print 111, and then 222, and 333. Then I will call the change values. What's going to be printed there? So if I write the printed values, this is what it is going to print in the first line. And then this method is called, what is it going to print? It's going to print the argument that is passed as 111, and then it will print numbers value, which is 222. And then for F3, again, it is going to print the same values, right? Any question? How is this executed actually? Once I have F1, it is another integer value that keeps 111. And then I have F2. What does it refer to? It refers to the same thing as this one, same object. And then I have F3, which refers to 333 when this method is called. Right? and it's going to print the same numbers. After this, what is going to happen? F1 equals 999. So I will update my F1 value to 999, right? And then I will have F2 set value 888. What does F2 point to? This object. So it's going to update the 222 to the corresponding new value. So this is going to be the new value. And then I have F3 new number 777. So what is it going to do here? So I will create a new object, a new number. So this is going to be my new number. And then it is going to point to this new number, which is going to update my pointer to point to this new object, right? So after all these changes, if I print the new values of F1, F2, and F3, as you can see, it's going to have F1 999, and then F2 888, and F3 as 777. And then the last thing, once we return from this method called, remember this is the change values which we just called. If I return back to the original caller, after this method call is finished, what am I going to do? I will print the new values of A1, A2, and A3, which will be A1 still 111. Remember, this is the integer, so it will keep its original value as 111. And then I will have A2, since F2 updated that, it is going to be 888. And then I will have A3 as before, 333. Okay, so this is going to be the new values of your arguments and variables. So if I happen to execute this, as you can see, it has 100, 222, 333, and the same numbers, and 999, 888, 777, and then 11, 111, 888, and 333 will be the last values. Any question? This is important. If you don't understand or if you have any concerns, it's a good time to ask. Okay. So this is, related to the objects passed as arguments to methods, and you should be careful with this kind of problems. And method overloading. So what is method overloading? So you define the same method with the same name but different arguments, and it will return it will mean the same thing with different arguments, so that you achieve the same result at the end. So if you give a single method name multiple definitions, that's called the method overloading. If the method is overloaded, the method name is not sufficient to determine whether it is being called or not, so you have to rely on the fact that they will have different signatures for each method call you have. So if you are overloading the method, the signatures will be different. The signature, what does it include in the signature? The number of the arguments that you have in your method and their types, right? So you have to include the number of type and their types of and order of the parameters. So for example, if you have a method that tells you, let's say, count method, which takes an integer and another integer, this is different than having, let's say, count int char method, or it is different than count char int. So these are all different overloaded methods with the same name, however with different arguments that you have. Again, the order and types are important. So for example, if you have two methods with the same name, float try me with an integer argument, and then another one, float try me with an integer and a float argument, then if you have an invocation of a method called result try me 25, 4.32, which one it's going to select is basically will be the second one, since it is the one that maps to the arguments. The important thing here is to note here is that the compiler should be able to understand which one of these it needs to select. If you want to be safe, you have to you have to be careful about that, so that you create your methods such that it can select either one of them. It will know which one to select easily by looking at the signature. So it will select this one, obviously. So if you look into the println method, we have different overloaded println methods, which one takes string, the other one takes integer, the other one takes double. So it's basically an overloaded method. And if you say, if you give an argument with the string, it will select the string version. If you have an integer, it will select the integer version of the println method. And this way, method overloading provides using the same method name over and over with different uses. Okay, so let's give a break, and then we will continue after the break.